Greetings, we have made it to the last cluster of standards. We have gone from kindergarten through 5th grade. As a reminder, in 278, if you need to take 278, we will cover the standards in grades 6 through 8, continuing to use manipulatives any way that we can. A good question to ask yourself or even think about is, when do we stop using manipulatives? And there's a ton of research out there on when one should stop incorporating manipulatives. But I think that as you get to know your students, students will just naturally just put the manipulatives away and start using algorithms. Some may take longer than others. There's just no real true set time. I still use manipulatives in my classroom, so if students need them, there's no reason why they can't use them. So our standards we're covering, our clusters we're covering this week are measurement and data and geometry. So here's a list of those that we need to cover with measurement and data. What is 24.65 multiplied by 10 and then by 100? In general, what impact does multiplying by 100 and by 10 and by 100 have on place value? From our place value chart, when we did numbers and operations in base 10, we know that multiplying by 10 means that 24.65 will be 10 times greater. So 24.65 becomes 246 and 5/10. We also know that multiplying by 100 means that 24 and 65/100 will be 100 times greater. So 24 and 65/100 times 100 is 2,465. Helen says all of the necklace cords are the same length. Gwen says that centimeters and millimeters are different from meters. So all of the lengths will be different. Who do you agree with? We have a color cord and then their lengths: 4 6/10 meters, 46 millimeters, and 460 centimeters. So I have our hundreds, or our regular place value chart, and then below it I have a meters chart. And so notice that they're color coordinated, and the exact same operations will be happening. A digit to the left is 10 times greater than the one to the right. This is true about a metric chart as well. So using our place value chart for meters, I can list that 4.6 meters, or 4 and 6/10 of a meter, would land right here on the chart, and 46 millimeters would land with the 6 in the millimeter category because that is the last name for it, and then 460 centimeters, the 0 ends at the centimeter category because that is where we land. That's where the last place value is. Oops. I see that 4 and 6/10 of a meter is greater than 46 millimeters. I also know that 4 and 6/10 meters is equal to 4,600 millimeters because meters are larger than millimeters. And centimeters and millimeters are different from meters, so their lengths will be different. Even though the black and the silver are the same, the black and the gold are different. Measurement of length can be expressed with different unit sizes because we can convert from larger to smaller units by using multiplication. When we convert between measurement units, the length of the item remains the same. So Helen and Gwen bought a 4th package of cord. This cord is orange and is 46 decameters of cord in it. Does the orange package have the same amount of cord as the black package? How do you know? So here is our chart again. Here I have 4.6 meters, and I also have 46 decimeters. Therefore, 4.6 meters is 10 times greater than 46 decimeters, but 4 and 6/10 meters is equivalent to 46 decimeters because if we look at the place value chart, they're in the exact same location, just named differently. Mickey and Minnie ran in a 3.5 kilometer relay race. During the race, they each had to run at least 2 times, but neither could run more than 4 times. Determine one possible running plan for Mickey and Minnie. Be sure to indicate the total distance each mouse ran and support your answer with visual models. We know the following, that it is a 3.5 kilometer relay race. They have to go the same distance. They have to run at least 2 times and not more than 4. So if they ran the whole time, we know that they have to split and be the same distance. So 3 5/10 divided by 2 is 1 75/100. Mickey could have ran 1 plus a half a kilometer plus a quarter of a kilometer, and Minnie could have ran 75 thousandths of a kilometer plus 5/10 of a kilometer plus another 5/10 of a kilometer. Or Mickey could have ran 1 kilometer plus 25 hundredths of a kilometer plus 25 hundredths of a kilometer plus 25 hundredths of a kilometer, still being within the at least 2 times but not more than 4 times. And Minnie could have ran 75 hundredths of a kilometer plus 25 hundredths of a kilometer plus half a kilometer plus a quarter of a kilometer. And this one needs to change too. So these are just 2 different possibilities. There are quite a bit you could have chosen to make this work. Mickey and Minnie ran in a 5K fun run. As Minnie ran, she started thinking about the fact that her stride equaled 1 meter. At the end of the race, Minnie told Mickey that her stride was the same as 1,000 kilometers. Mickey said that she had it backwards, that her stride was the same as 1/1000th of a kilometer. Who do you agree with and why? So as we move left on our chart, we divide by 10. So 1 divided by 1,000 is 1,000th. 1 meter is equivalent to 1/1000th, oops, I have too many zeros, I apologize, of a kilometer. So therefore, Mickey is correct. So we went from a meter 10 times, 100 times, 1,000 times, divided by. Mickey and Minnie are at it again. Mickey says that 1 centimeter is equivalent to 1/10 of a meter. Minnie says that 1 centimeter is equivalent to 1/100th of a meter. Who is correct? Well, 1 meter is 100 times greater than a centimeter. So 1 centimeter is equivalent to 100th of a meter. The ship sailed 5 kilometers. How far is that in meters? So we're going from kilometers to meters, which means that we are going to multiply by moving right 10, 100, 1,000. 5 times 1,000 is 5,000 meters because kilometers are 1,000 times larger than a meter. Drake rode the unicycle 52 thousandths of a kilometer. How far was that in meters? So again, we're going from kilometers to meters, so we need to multiply by 1,000. So 52 thousandths times 1,000 is 52 meters. The height of the tube of tennis balls is 254 millimeters. What is the height in meters? This time we are going from millimeters to meters. So we will need to divide because meters are larger than millimeters, or millimeters are 1,000 times smaller than meters. So 254 millimeters divided by 1,000 is 254 thousandths of a meter. Some friends canoed 37.9 meters down a river. This was how many hectometers? So we're going from meters to hectometers. Hectometers are much larger than meters, so we will need to divide by 10 by 100 in order to get 379 thousandths hectometers. Minnie is making necklaces to sell. She wants to buy more cord to make more necklaces. She has visited 5 different stores to compare prices. She has made a table that shows the length and price of cord at different stores. Let's help Minnie choose the best option. So above at the top of the screen, I have our meter chart, and I have some different items. When I look at the cord lengths, some are in centimeters, some in meters, and some in millimeters. I think it would be best if we converted all of them into centimeters to really get a look for things. So when I look, we're going to start at store C. 7/10 of a meter times 100 would give me 70 centimeters. So I'm filling in what the centimeter portion is. Store A is already in centimeters, so we'll just carry that down. Looking at store D, 1,400 millimeters is how many centimeters? So going from millimeters to the left, one box, we need to divide by 10, so it would be 140 centimeters. Store B is already in centimeters, so I carried that down. Finally, store E is 1.4 meters. We are moving to the right 10, 100. So multiplied by 100 is 140 centimeters. When I compare looking at all the centimeters, when I look at the 70 centimeters, the best cost is store C. When I look at 140 centimeters, the best cost is store B. So it's kind of between the two of these. What I can do is double the centimeters, 70 centimeters, double that and double the cost so that we get to 140. So $6.99 times 2 is $13.98. When I compare $13.98 to $13.95, I see that $13.95 is the better deal at store B. Mrs. Boyd measures and lists the widths in inches of books that will be placed on the travel shelf. Help her organize the data by completing the line plot. 1/4 is already placed for us on the line. Then I need to place a dot at 3/4, one at a half, another at 3/4, and now to get 1/8, I also see that my whole unit line is also divided into eighths as well. So I can place one at 1/8, I can place one at 1/2, I can count 5 copies of 1/8 to get to 5/8, another 3/4, and a 1/2. Ethan recorded the amount of rainfall in inches. Let's interpret this data on a number line to help him answer some questions on our report. So I see the following days are listed there. I have a number line. I know that based on doing the problem, I needed an extra piece just outside of 8/8. I needed a 9/8 location, so that's what that one represents. All right, so let's start sketching. On day 1, the rainfall amount was 1/8, so I'll put a dot above 1/8. On day 2, it's double day 1, so we need 2 copies of 1/8, so 2/8. On day 3, we need 3/4. We know that we can combine 2/8 together to create a fourth. So here would be 1/4, 2/4, 3/4 at 6/8. On day 4, it's a 1/4 inch less than day 3. So day 3 was 3/4. So a quarter less than would be 4/8. Day 5 is 1/8. So we'll put another portion on 1/8. Day 6 is 1/2, which is the same as 4/8. Day 7 is day 5 and 6 combined. I know that 1/2 is the same as 4/8 plus 1/8 gives me 5/8. Day 8 is 3 times as much as day 1. So 3 copies of 1/8 is 3/8. We need 1 and 1/8 for day 9, so we need to go to 9/8. Day 10 is a quarter inch less than day 9. So again, we're in eighths, so I need to take 2 jumps to get to a quarter inch less than at 7/8. We have another at 1/2. We have another at 3/8. Day 13 is day 11 and 12 combined. Again, 1/2 is the same as 4/8 plus 3/8 is 7/8. And then day 14 is 5/8. So we've combined them all together onto a number line chart. The tomato plants should receive 8 inches of water in 2 weeks. What can we say about how much water the plants received? So we'll need to add them all up. So I have 2 copies of 1/8 plus 1 copy of 2/8 or 1/4 plus 2 copies of 3/8, 3 copies of 1/2, 2 copies of 5/8, a 3/4 or a 6/8, 2 copies of 7/8. Oops, and I forgot to add this one. Plus 1 copy of 9/8. Multiplying 2 times 1/8 is 2/8, 1/4, 2 times 3/8 is 6/8, 3 times 1/2 is 3/2, 2 times 5/8 is 10/8, plus 3/4 plus 14/8 plus 1 and 1/8 or 9/8. I can combine some pieces together. I take a look at 2/8 plus 6/8 gives me a whole. I take a look at 1/4 and 3/4 and I also get a whole. And I can do that throughout. And ultimately, when I have all of them partitioned together, we get 7 and 5/8. Well, a tomato plant should receive 8 inches. We didn't quite have enough water. So Ethan might want to think about watering himself an extra 3/8 of an inch on non-rain days. Drake made a line plot for the amount of time he spent on homework each night. Drake's parents want him to spend 5 hours a week on his homework and reading. How much time should he spend reading this week? I noticed that I'm grouped into 1, 2, 3, 4, 5, 6, 7, 8. So we're grouped into eighths. I have 1 1/8, 3 copies of 2/8, 2 copies of 4/8, and 1 copy of 6/8. So when I multiply, I'll have 1/8 plus 3 times 2/8 is 6/8. 2 times 4/8 is 8/8 plus 6/8. Altogether, we have 21/8, which is 2 wholes and 5/8 left over. He's supposed to spend 5 hours a week on homework and reading. So 2 and 5/8 hour is spent on reading. That means we need 3/8 more of an hour to reach 3 hours, plus 2 more hours to reach 5 total hours. So Drake will need to read for 2 and 3/8 hours to reach his 5-hour goal. We use line plots to record the frequency of data and to help us see what the data look like. Different ways data are organized helps us answer different types of questions. I ran every day for 2 weeks. Looking at the line plot, what can you tell about the pattern of the data? I could say that I usually run between 1 and 2 miles a day, since that is where the majority of the data lines lie. Let's say we want to know how many unit cubes will fit in the box, but we don't want to count them all. We know there are 5 columns across, 5 rows back, and 10 cubes high. Determine how many cubes are in the box. Well, I know that each layer will have 25 cubes, since 5 times 5 is 25. There are 10 layers of cubes, so 25 cubes per layer times 10 layers is 250 unit cubes. We have 120 cubes in a variety of different storage containers. Which container could we use to pack all 120 number cubes in without leaving any extra space? Cube A is an 8 by 5 by 3, so 8 times 5 times 3 is 120 cubic units. We could use storage container A. Storage container B is 10 by 10 by 2. That is 200 cubic units. That's too many. We can't use that one. Container D is a 60 by 60 by 1. 60 times 60 is 3,600 times 1 is itself. Again, way too big. Part C is a 3 by 4 by 10. So 12 times 10 is 120 cubic units. We could use letter C. Letter E is a 30 by 2 by 2. 30 times 2 is 60 times 2 is 120 cubic units. So we could use containers A, C, and E to store our 120 cubes without leaving any extra space. Multiplying the length, width, and height of a right rectangular prism, we can find the volume, or the space that's inside the container. How can we efficiently find the volume of this figure when I know that the base area is 48 square millimeters and the height is 20 millimeters? I can take the area of the base and multiply it by how many layers we have. Since we have 20 layers, we will take 48 times 20 to get 960 cubic millimeters. If the volume of the right rectangular prism is known, how can we use that to find a missing measure? So I know the volume is 240 cubic yards. I know that I have 6 layers of equal amounts. I can then take volume, which is area of base times height, and we know the volume is 240. We're unsure what the base is, but we know that there are 6 layers. So using our properties of multiplication and division, I can take 240 divided by 6 layers, so each layer is 40 square yards. How can we find the volume of this irregular figure? Well, notice if I split it down the middle here, I have 2 right rectangular prisms that we know how to find the volume of each. So looking at the one on the left, I can take 12 times 5 times 15 for 900 cubic inches. I can find the right rectangular prism on the right by taking 12 times 12 times 15 for 2,160 cubic inches. Altogether then, I have 900 plus 2,160 for a total of 3,060 cubic inches for this irregular figure. Find the volume of this figure. Take a moment, pause the video to see if you can do it. Again, splitting it down the middle, I see that I have 2 separate right rectangular prisms. On the left, I take 20 times 8 times 25 for a total of 4,000 cubic centimeters. On the right, I can take 25 times 5 times 8 for 1,000 cubic centimeters. But because they are combined, I need to add them together. So 4,000 plus 1,000 is 5,000 cubic centimeters. An irregular solid figure can be decomposed into right rectangular prisms to determine volume. And we know, we just seen that volume is additive. Some geometry that we need to cover. Identify the coordinates for point A, point B, and point C. Coordinates are when we can identify the location of the point on a plane. We have an x-axis that runs horizontally and a y-axis that runs vertically. Where our horizontal and vertical axis meet in the middle is called the origin. This is where we start when we want to identify a point. So when I look at point A, I must go to the right 3 units and up 3 units as well. To find point B, I move right 7 units and up 4 units. So its location is 7, 4. Notice I put the x value first and the y value second. Point C, I'm not moving left or right, I'm moving straight up. So that is the point 0, 7. Plot the ordered pairs on the coordinate plane. What letter is formed by connecting the points in order? The point 1, 1 means I move right 1 and up 1. 1, 3 means I move right 1 and up 3. 1, 5 is right 1, up 5. 3, 3 is right 3, up 3. 5, 5 is right 5, up 5. 5, 3 is right 5, up 3. And 5, 1 is right 5, up 1. Connecting the points in order, I see that I have created the letter M. A line segment is drawn from 2, 3 to 6, 7. Another one is drawn from 4, 1 to 8, 5. Where could another line segment that is parallel to these two segments be drawn? Name the two endpoint coordinates. Here is 2, 3 to 6, 7 connected with a line segment. Here is 4, 1 to 8, 5 connected with a line segment. I could place a point at 3, 2 or 1, 4 or 0, 5, but one possible segment endpoint coordinates are 1, 4 to the point 5, 8. Name the ordered pairs that represent the endpoints of the two line segments that run parallel to one another in the trapezoid. Remember that parallel lines are equal distance from each other and never touch. So line segment A to B from point 2, 5, so 2, 5 to point 5, 5 is parallel to line segment CD, the point 1, 3 to the point 6, 3. Determine how many spaces are traveled on the yellow path from point A to point B on the coordinate plane. From point A, we move right along the axis 1, 2, 3, 4, 5 times. Then up along the y-axis 1, 2, 3, 4, 5 to reach point B, for a total traveled distance of 10. Describe the location of point T in 3 different ways. The first way is naming its point. 4, 6. The x-coordinate is a distance of 4 from the y-axis and a distance of 6 from the x-axis. Point T is 4 units to the right of the origin on the x-axis and 6 units up from the origin on the y-axis. So just different way of explaining how to get to the same location. Interpret the values of point A and point B. If I take a look at my x-axis, this talks about the number of weeks. On the y-axis, this is the number of books checked out. So point A represents that during week 2, there were 75 books checked out at the library. During week 7, there were 100 books checked out at the library. Interpret the values of point A and B. Give it a try. The x-axis represents the number of days. The y-axis represents the number of brownies sold. Point A represents on the 3rd day, 50 brownies were sold. Point B represents on the 8th day, 70 brownies were sold. We can interpret coordinate values of points in the coordinate plane. Use the table to answer the questions. I have some data on the female giant panda growth, and I have a chart down here. Years is on the x-axis. Y represents the weight. Graph the corresponding points and see what you discover about female giant pandas. Connect the points in the order they are given to form a line graph. What does the point 0 years 1 kilogram mean for a typical female giant panda's weight? So I have the arrow pointing there. So when female giant pandas are newborns, they weigh 1 kilogram. How heavy do you think a typical giant panda will get, and why? Up above, I have circled in red, or put a square on red, that the graph shows that female pandas reach a weight of 100 kilograms. And because none of the points given have a larger value than 100, we can assume that they typically weigh about 100 kilograms. At what age do female giant pandas reach their full weight? How does the graph show that? This time I'm going to refer down to the years. Female giant pandas appear to stop gaining weight at 5 years old. Therefore, the female giant panda's weight stays the same at 100 kilograms. Decide whether each of these statements is always, sometimes, or never true. If it is sometimes true, draw and describe a figure for which the statement is true and another figure for which the statement is not true. A rhombus is a square. This is sometimes true. It is true when a rhombus has 4 right angles. It is not true when a rhombus does not have any right angles, because a square must have 4 right angles. So on the left is a picture of a rhombus, on the right is not a rhombus. A triangle is a parallelogram. Never. A triangle, we know, is a 3-sided figure, and a parallelogram is a 4-sided figure with 2 sets of parallel lines. Since a triangle can never have 4 sides, it is never true. A square is a parallelogram. Always true. Squares are quadrilaterals with 4 congruent sides and 4 right angles. They also have 2 sets of parallel sides. A parallelogram are also quadrilaterals with 2 sets of parallel sides. Since squares must be quadrilaterals with 2 sets of parallel sides, then all squares are parallelograms. A square is a rhombus, so the opposite of A. Always true. Squares are quadrilaterals with 4 congruent sides. Rhombuses are also quadrilaterals with 4 congruent sides. Squares are, by definition, also rhombuses. A parallelogram is sometimes a rectangle. It is true when the parallelogram has 4 right angles. It is not true when a parallelogram has no right angles. A rectangle must have 4 right angles. A trapezoid is a quadrilateral. Always true. Trapezoids must have 4 sides, and that is the only condition to be a quadrilateral, so they must always be quadrilaterals. The picture below is called a Venn diagram. Each circle, A, B, and C, so the pink, blue, and orange circle, contain shapes that share at least one characteristic. Some shapes are contained in more than one circle because they share more than one characteristic. Take a moment, stop the video, and see if you can identify What are the shared characteristics by shapes within circle A, the shapes that are shared within circle B, the characteristics shared within circle C, and where would you place a rectangle that does not have four sides of the same length, and why? When I look at those items in circle A, I see that they are all triangles. When I look at the items in circle B, I see that they at least have a right angle. When I look at letter C, I see that all of their sides have an equal length. And I would place a rectangle that does not have four sides of the same length into circle B. A rectangle without four equal sides must be placed in the circle for shapes with right angles. Since they don't have equal sides, it cannot go into C, and it's not a triangle, so it can't go in A. It also must not overlap any of the other sections, so it has to stay in the main blue area.